Okay, so here we have now a small version. We're done with the cars and trains. We're going to small things like bullets. Okay, and this is important because it's a violent world and you have to find out how dangerous guns are. Okay, so we have a bullet coming. This is the barrel of the gun, right? And the bullet is coming out and is being accelerated, right? The bullet starts with an initial velocity of 0 because it says here rest, and rest means VO is equal to 0. This is the mass of the bullet, M, and it's being accelerated, and this is the final velocity, VF, right? So the final velocity is 300 meters per second as it leaves the barrel. This is your VF, okay? And then the barrel is 20 centimeters long, so that's the D. Okay, and here we have our given. First, we have our distance traveled is 20 centimeters, but you have to convert that to meters because the solutions must always be in meters and in kilograms. So 1 meter over 100 centimeter. Cancel, cancel. It's going to be 0.20 meters. And remember, don't change the significant figures, right? If this is two significant figures, this should also be two significant figures. The mass is 12.0 grams. Okay, and so, again, divide it by 1 kilogram is divided by 1,000 kilograms. You cancel that. It's going to be 0.012 kilograms. Okay? So, how do we solve this problem? We're looking for the force. And our Newton's second law formula is force is equal to mass times the acceleration. We have the mass that's given. We don't have the acceleration. So we have to solve for this acceleration. And we have two ways of solving. If time is given, then we use equation number 1. But here, we're given the distance, so we have to use this equation, motion equation, to solve for acceleration. So acceleration is the final velocity squared minus the initial velocity squared divided by 2d. Okay? So we're going to write that here in our solution. Acceleration is final velocity squared minus initial velocity squared divided by 2 times d. Substituting the values, 700, and this one is 0. Meters per second, you square that whole thing, you divide it by 2 times our d is this one, 0.20 meter. And the answer is going to be very big. 1,000,000 meters per second. Okay? Squared. Okay? So this can also be written as times 10 to the 6 meters per second squared. And that's better because that's scientific notation. Okay, so now we're going to solve for the force in newtons. And remember, to get newtons, you have to have kilograms times acceleration in meters per second squared. Okay, so in kilograms, it's 0.012 kilograms times 1 times 10 to the 6 meters per second squared. And the answer here is in newtons is and again, if you want to stay with scientific notation, times 1, 2, 3, 4. 10 to the 4, I think. Anyway, verify. Okay. Either one. This is thousands of newtons is acceptable.